Good day, my name is Evgeny Cherkashin and I, with my colleagues from Institute of Earth's Crust and two educational universities, would like to present this talk named Web-GIS Viewer for Active False Data, represented as Knowledge Graph. At the conference IWCI 2021, we stated problem of integration of geological data of various sources into one knowledge graph, and we decided to make software to make this data easy accessible, a kind of standardized representation to allow integrate various data sources of similar structure, in the same time to provide reuse of existing data sources for domain modeling. As well as we would like to support big data paradigm, and finally to construct software for maps dynamically. Some steps are already fulfilled and we present the results in this talk. Why we should use knowledge graph? The main advantage as compared to general JS system, which probably use relational tables for layer data, for accompany layers with additional data, it's a more flexible structure for data representation. Most of JS systems do not support knowledge graph. We chosen Web 3.0 technologies to support this idea. These technologies allows us to integrate different software in internet, and utilizing knowledge graph technologies allows us to store not only data but also metadata. We can develop software for publishing and processing in the same time. Using knowledge graphs allows us to postpone formal definition of scheme of data. I would like to specially note that theoretical basis of knowledge graph usage allows us to represent them in three different views, showing semantic, that's relations between classes. For example, validating semantics, we can use some automatic procedure to verify relations between entities, and emergent, which implies the capability of research groups to reconstruct knowledge graph when it is necessary to upgrade its structure. Another aspect of data publishing within semantic network is level of compliance to linked open data, so-called standards. 5-star compliance will require from data. Most of entities should be linked to another entity's descriptions. Use V3C standards for publishing for resource description framework, and all data should be openly published. Our project is to develop a geological data viewer for data accumulated in Irkutsk Earth Crust Institute, Siberian branch of Russia Academy of Science. We are to implement JS, which can represent SPARQL endpoint data, convert existing data into a resource description framework, respecting link of data principles, implement natural language interface in the image and likeness of GeoBase program, provide versioning data transfer between viewer and GIS software, and implement various analytical functionality for domain problem solving. It's application. What about our results? We deal with faults. Faults are linear object having linear projections on the surface, but they have various characteristics. For example, depth and slope in lithosphere. Each fault is accumulated by various valued characteristics as well as additional metadata on these values. For example, precision and related publications where this characteristic was determined. As of today, our viewer can only show faults, filter them according to relations values, and show additional information after pointing fault shape. Here we present the results of viewing fault data. The screen consists of map and control panel where user can choose various filtering conditions, width of lines, their color. In order to show information about specific fault, user choose the fault by means of mouse. All known information in the knowledge graph are rendered into this form. One of my students decided to make debugging window where a user could make auxiliary SPARQL queries. SPARQL server returns table of objects. The first column should be name of fault. This slide shows data representation for one fault. At present, the resulting vocabulary is flat. We have only one subject, it's a fault. Everything else is either reference to an URL or value. In the future, we should respect other values of entities, for example, earthquakes, as an individual objects. This ontology was obtained by processing a relational table data of this structure. Analysis of data stored in the database showed that most of columns have null values. The conversion to the knowledge graph allows us to represent these flexible data structures in a more convenient way for further processing. To implement this viewer, the following technologies were used. The topological basis is loaded from OpenStreetMap, but it is not restricted only by this server, because Leaflet JavaScript module also supports other topological basis sources. The application is implemented in Reactjs component architecture, and Leaflet library is also wrapped by an component of this framework. The vocabularies are stored in GraphDB and Apache Genus servers. We compared them. We did not mention any difference, except that GraphDB has very convenient user interface for vocabulary loading and SPARQL queries testing. The state dynamics of the application is implemented by Redux. Shapes are represented as JSON objects and they are loaded with application. All conversion procedures were mostly implemented by Python modules. Bachelor student could implement this viewer in 1.5 months, knowing previously nothing about knowledge graphs, Leaflet properties. The target architecture of the environment we'd like to construct is shown in this slide. Now we have implemented this unit and we have already implemented part of authoring tools which could be used to create documents, text index engine, knowledge graph server. Potentially we can use other SPARQL servers, for example DBpedia, to show additional information. We have technologies to implement graph data processing. These technologies are based on Locktalk programming language. And most complex problem is to involve existing JS systems in knowledge data processing. This software will be used in research of Olkhon Island pollutants in Institute of the Earth Crust, Siberian branch of Russian Academy of Science, which is located in Irkutsk. And one of interesting problems is to relate the pollutant sources with faults. As of today, we have a short review of similar projects, and we tested technologies for knowledge graph construction. It was successful. The project showed its relevancy in sense of application standards of data publishing. We implemented the Web-GIS viewer for faults, and the further we need to join digital archive, produce JS application for Olkhon Island pollutants, try to research the fault impact of pollutants, and in the far perspective we would like to construct viewer for external fault data. The main aim of our project is to develop research environment for publishing and processing geological data. Thank you very much for interesting in our project.